Hello and welcome. I'm Tim Dry, Director of Marketing for Edge and Endpoint Applications at Samsung Foundry. The performance and power requirements for Edge and Endpoint applications vary immensely, from the smallest of endpoints, such as connected building sensors, to streaming applications with higher performance requirements, such as 4K video surveillance cameras, and then out to the edge, where edge processors can have the highest compute requirement. All applications are power sensitive, be it for the battery life, the size of the battery, size of the power supplies, and for thermal mitigation, which may dictate the use of fans, heat sinks, or expensive and heavy cooling systems. Many endpoint and edge applications are adopting AI with machine learning in their architectures. This to offset the processing loads and enable processing to be local to the application, removing the latency in having to go out to the cloud for processing. Samsung Foundry has a portfolio of solutions that address this breadth of diverse requirements. For endpoints requiring long battery life, Samsung has FD-SOI processors that provide performance on demand and dynamic power control. For the streaming applications and the edge processors requiring the higher performance compute capability, while still meeting their power and thermal budgets, Samsung offers its family of advanced FinFET technology. Samsung was the first to market with 14nm FinFET and is continuously evolving its advanced node roadmap, offering an 8nm and now a 5nm EUV FinFET offering. Each new family member providing an increase in performance at reduced power and improved scaling to meet the increasing PPAC demands. Beyond FinFET, Samsung is the market leader in GAA, that's gate-all-around architecture, which has been developed to meet, again, the increasing performance requirements at the edge, HPC, automotive, and mobile segments. Now, process technology is part of the solution. Samsung also ensures that IPs are readily available and they're optimized to the process technology to again achieve the best PPAC. Additionally, Samsung is driving innovations in 2.5D, 3D packaging with chiplets to provide heterogeneous solutions that extend Moore's law and enable the next generation of edge processors and HPC high-performance compute platforms. Now, if process technology, optimized IP, and packaging are the building blocks, then the glue is the design enablement, the tools, the design services that come from our ecosystem of safe partners to ensure a successful project. We're here today to share one such customer success story for an AI accelerator solution targeting multiple edge and endpoint applications. This story is not only about the clever use of world-leading technology, but more so about how the partnership between our customer Blaze and our safe design partner VeriSilicon, together with Samsung Foundry, all collaborated to make this project and the product a success. So I'm very pleased to have with me online today Santiago Fernandez Gomez from Blaze and Mahadev Kaluru from VeriSilicon. Welcome, gentlemen.
Hi, Tim.
Thank you, Tim.
So I'd like to start with some brief introductions. Santiago, will you please do the honors and introduce yourself and Blaze?
Thank you, Tim, and thank you for having me here. I am the Vice President of Platform Engineering at Blaze. I am responsible for the delivery of all products that our customers see on the hardware and software side. Regarding Blaze, Blaze is a new generation computing company. Driven by the advances in energy efficiency, flexibility, and usability, Blaze processors and software enable a range of existing and new AI use cases in the automotive, smart vision, enterprise, and computing segments. Our core technology, the Blaze graph streaming processor, delivers breakthroughs in the energy-efficient computing required for AI data workloads. With Blaze, developers can innovate new classes of products to bring the benefits of AI and machine learning to broad markets.
Great, thank you. So Mahadev, if you can briefly introduce yourself, your function, and a few words on VeriSilicon, please.
Sure. Thanks, Tim. Hi, everyone. My name is Mahadev Kaluru, and I'm a VP of Business Development for North America at VeriSilicon. Founded in 2001, VeriSilicon has been offering one-stop solutions provisioning for customers through our Silicon Platforms as a Service engagement model. With over 1,000 employees, 6 R&D design centers, 11 sales and customer support offices worldwide, VeriSilicon provides a comprehensive suite of IP solutions and spec-to-production silicon turnkey services to customers for a wide range of applications.
Fantastic. Thank you very much. So I'd like to start by understanding what is this AI at the edge. And Santiago, I'm going to start with you, please. Yeah, how does Blaze define AI at the edge, and what applications are you targeting?
We actually agree with the definition that AI edge devices are those that provide computation with latencies less than 20 milliseconds, either on device, near edge, or edge cloud. For applications, we're actually focused on AI-enabled smart vision in the automotive and industrial markets. Smart city, retail, factory, and mobility are some examples of them.
And why do they need AI at the edge? What's driving this requirement?
Invention at the beginning was in the cloud, but now is quickly changing with migration towards the edge. Why? Multiple factors, but practical day-to-day applications happen at the edge. 5G is one of plays a role here. AI is integrated into a very large range of products nowadays, with quite diverse use cases. They all have different compute requirements. Our GSP architecture is pioneering these use cases, providing the ability to efficiently compute AI where the data happens at the edge.
So it's closeness to the application and reduce the delay out to the cloud.
Much closer.
Yeah, understood. So Mahadev, from a designer's perspective, what do designers need to consider when they're designing these edge AI processes?
Sure. In designing AI at the edge kind of chips, it's important to have firstly an proper understanding of the customer target application requirements and their usage scenarios. Just as Tim was mentioning, there's a lot of compute that's going on in these devices at the edge itself without having to go to the cloud. So domain expertise helps in defining an efficient SoC platform architecture that can deliver these high performance compute capabilities at the edge within the edge device itself at the right power, area, and cost metrics, while also leveraging the process node advantages that are offered, particularly for the designs that you're doing in whichever process node, and in this case, with that's offered by foundry partner Samsung. Edge AI chips, like Santiago and you just mentioned, are getting more complex with a lot of computations happening in the device. Content analytics, real-time decisions are being done within the edge device itself without having to go to the cloud. So it's important that these devices actually support high computation capabilities at the lowest power possible. That's the challenge in the design.
Always the challenge. PPAC, right? Hi. Thank you. So I want to talk about how this project came about and how the three of us all connected. So Santiago, I'm going to start with you again. Why did you choose us, Samsung Foundry, as your foundry partner?
Well, in the space we are, Samsung is one of the very small list of foundries that have the capabilities to actually address the high performance we require. In addition, I have worked with Samsung for over 20 years, and I have first-class experience on their capabilities, and especially their commitment. I was quite impressed by the ecosystem that they have lately built on these technology nodes, which is a very important part of our decision.
So experience and we have the technology, right? So that sounds like a winning combination right there. So, and then working with VeriSilicon, what was your criteria for selecting them as a partner?
Well, we actually, as an ISO certified company, we have a very strong QMS system, and we look at aspects like technical support, ecosystem, financial, and business, in addition to strategic reasons for selection of vendors. VeriSilicon actually fit all of them. We did a complete 360 evaluation before picking them, and they came out as the winner.
Very good, thank you. So, and then working with the three of us, what other factors and things have occurred between our collaboration? Is there one thing that sticks out, or a couple of things?
Well, I have to say the collaboration from day one was seamless. It's not that common that a company like us works with multiple companies at the same time on one project, especially a foundry and a third-party vendor. Usually the model is you work with a third-party vendor and the foundry gets a little bit shielded by that. That was not the case in this situation. We had eight locations with 8 different teams working together literally weekly on every issue. The foundry in particular, Samsung, brought solutions to the table beyond the standard flows to address any of the challenges that we have in implementing our technology.
So around the clock, around the globe, nearly
Yes.
24/7, right? So
Yes, especially 3 companies on the same problem on a daily basis is really how synergy of technology happens.
great. And for this project, what process node did you ultimately go with?
At the end, we selected 14 LPP from Samsung. We actually did evaluation on different nodes, and even we did uh, run our technology through several of them. And 14 LPP was definitely the one that provided the best performance, cost, and power for our needs.
Great. And as I mentioned, first to market, 14, so quite mature. Lots of millions of wafers sold actually. So low risk from that point of view. So Mahadev, I'm going to ask you actually, what in your opinion made 14 LPP the best process for this project?
Yes, Tim. So based on the specification requirements for Blazer's first AI at the edge chip and the availability, of course, of all the IP silicon proven IP that was needed for this project, the process node maturity, the yield metrics that you just talked about, like shipping wafers in lots of volumes already by the time this project started with Samsung, and the cost performance balance, right? All of these made Samsung's 14 LPP as the best option for this project, which is why based on our collaboration, long-standing collaboration between VeriSilicon and Samsung, we found that this was the best possible option for this specific project. And also as a startup, it was very important for Blaze to have the right platform architecture for this first chip that they were doing that essentially can become like that they can actually derive multiple products out of this, targeting their breadth of portfolio that they want to, that they have in the roadmap, like consumer, industrial, automotive applications, all leveraging their proprietary graph streaming processor technology. So that's Samsung 14 LPP made the best sense at the time for this.
Great. Great. And then how did VeriSilicon work to meet Blaze's project goals? We heard already that they have facilities all around the globe. So what did VeriSilicon do to meet those goals?
Just a quick insight into that. Dr. Wayne Dye, who is our VeriSilicon chairman, president, and CEO, and he's an industry veteran, he actually likes the challenge of supporting startups while we deal with large companies and the breadth of the companies. So he likes the challenge of supporting startups that demonstrate a passion for introducing new products and differentiating products into the market through their innovative technology. Blaze, I think when we worked with Blaze, we realized their single-minded focus in terms of bringing the first high-performance AI at the edge kind of a chip solution for these different market segments. And that really was something that appealed to our VeriSilicon management team and started the path of a strong collaboration between Blaze and then, of course, with Samsung after that through our IP and services collaboration. One of the biggest challenges for this project was, as you mentioned earlier, the PPA part of it. It is to deliver the highest compute performance per millimeter square and per milliwatt in the smallest possible form factor, while that is optimal for an edge kind of a device. So we worked closely with Blaze, Samsung, and Safe Ecosystem. VeriSilicon actually took the right steps in terms of the architectural decisions, design implementation trade-offs that were reviewed within the teams across all of our 3 companies, VeriSilicon, Blaze, and Samsung, in different geographical locations, all working together to figure out what would be the right design implementation techniques to use, what's the right architecture, how the right data flow happens. Effectively, all of these adding towards the right architecture for this kind of chip for the edge. And also the first silicon success was achieved and also met their aggressive schedules and at the right PPA numbers. So that's
very impressive. I want to expand on what you mentioned about the PPA just then. Was there anything you did, special sauce perhaps, that you added to Blaze's GSP design that improved the PPA? Anything you can share?
There are, I think, during the course of the project, there have been many things that have been done. Like, for instance, right from the focus that the teams had in designing the graph streaming processor itself, right? I mean, the initial, the kind of performance that they wanted to put into pack into a per millimeter square kind of area. Uh, Initially, of course, Santiago knows and rest of the team, I mean, the size actually blows up, and then you have a lot of work to try to get that down to a reasonable size that becomes the right cost point as well, and the right performance. And there's a lot of design techniques that Samsung in 14 actually in LPP provided in terms of different libraries and different design technologies, design methodologies. There were, of course, the traditional stuff that we do in terms of power island, clock gating, voltage islands, and stuff like that. So leveraging all of the those design principles that are commonly known, but also the design implementation technologies that Samsung 14 LPP offered to VeriSilicon and Blaze, we were able to take advantage of all of those for this project.
Great, and we all know that every project doesn't always run as smoothly as we'd like. But is there any challenges that came up that yourself with Blaze and maybe even Samsung addressed? Anything you can share here, or some process, some method of offsetting that perhaps that VeriSilicon adopts?
Yes, sure. I mean, of course, like you said, there's always different challenges throughout the phase of execution of a project, but especially of this kind of a complexity and target specs. But I'll just share one recently. I mean, because of the global COVID-19 pandemic, the whole semiconductor industry, as you know, is going through a global supply chain issues, right? I mean, including substrate material shortage, things like that. So with a proper proactive and effective supply chain planning, our three companies were actually able to overcome the situation. We were able to secure enough raw material supply, enough wafer capacity, and to move forward with Blaze's production plans without any interruptions or delays. And that's making this chip a reality for Blaze and the rest of us.
Great, great. So it's very clear to me, talking with the two of you here, that you've enjoyed a very productive partnership with this project. Now I'd like to stick my head in the lion's mouth and ask what it's been like working with us, Samsung Foundry. So, so Mahadev, I'm going to ask you actually, from your perspective, what are the benefits for a startup like Blaze, to partner with Samsung Foundry and our safe ecosystem?
So as you indicated, with 14, Samsung was already shipping several thousands of wafers or tens of thousands of wafers, many designs already in production. So the maturity of the process node was a big plus. And then leveraging all the proven these technological innovations that were proven, the IP solutions that were proven from both Samsung and its safe ecosystem, I think this helps risk mitigation for startups like Blaze, who are eager to introduce value differentiating solutions into the market and make a difference in the industry, right? I mean, that's what they wanted to achieve. So working with ecosystem of Samsung and the safe ecosystem on using proven technologies and proven IP solutions is the right first step. And that's what brings a lot of value and stability and risk mitigation for startups like Blaze. And of course, the strong technical support that we received throughout the execution from Samsung Foundry for VeriSilicon, we are a safe ecosystem partner. And this helped enable shorten the turnaround time and the design cycle time, and also the design risk from a VeriSilicon as a silicon services vendor point of view. Those are very important. And because of all this close collaboration between the teams, faster turnaround time was achieved, and also delivering first silicon success was also possible. And these, just like you mentioned, right, I mean, these are key to a startup's success and future growth. So these Samsung Foundry and the safe ecosystem actually added a complete compelling value add benefits for the large companies as well as startups like Blaze. And that really in the end was instrumental in our three-way collaboration to make sure that this first time silicon was a success story for Blaze.
That's very good to hear. First time silicon, that has a lot of value, I believe. So Santiago, from your perspective, what are the benefits for a startup company like yourselves, working with us, Samsung Foundry, and then our ecosystem partners, VeriSilicon?
So let me highlight a couple of them. Mahadev mentioned some of them earlier. We also discussed, but I would say beyond that, the top two are risk and support. On the RIG side, we are a startup. We don't have the liberty of producing multiple silicons. We had to be successful the first time in this technology. And we had to not only get our silicon back and working, we had to get our silicon in production. And I have to say that with help with Samsung Foundry and VeriSilicon, we not only achieved that, we went beyond that. Our silicon was here early June. We are already in risk production, less than 4 months. Never happening before to me. And we will be in full production by the end of the year. The risk was completely eliminated by going with Samsung and VeriSilicon. The second one is support. If you have been in the industry as long as I have been, small companies don't get any attention from foundries. That has been traditionally the situation. There's always been turnkey in front of them to deal with everything. Not anymore. Samsung made a strategic decision to actually support small companies like us with cutting-edge technologies. And I can tell you that our support goes all the way to Korea, the engineering teams, whatever we need. We feel that we are right there getting the best support that Samsung can provide, not just the front-end phone support that we used to get years ago with other companies.
So very trusted support, quick responses.
Not only trusted, it's just technical support. For anything, we can trust that someone who is developing the technology in Korea is going to get involved if they need to resolve an issue that either us or VeriSilicon have with our implementation. That has been like that from day one of this partnership.
Excellent. So gentlemen, it's been a pleasure to talk with you. Thank you very much for sharing our success story, your success story with us. And so we're going to wrap it up here. So until next time, I'm Tim Dry. Thank you very much.